is Jeopardy!
Good morning, second period. My name's Kelly Matlock, and I'll be your host on the very first ever Physics Jeopardy! Now it's time to meet our contestants. Emily Jarnigan, basketball, volleyball, and physics superstar. Isabella Hill, choir nun by day, rap star by night. First question. A 4-kilogram box is being pushed by Mr. Jordan to the right at 60 newtons and Mr. Hammock to the left at 20 newtons. Draw a force diagram of the situation. First person to finish their diagram and explain it correctly wins the point.
I have it! I got it. Force of the ground on the box and force of the earth on the box are equal. And then also the force of Mr. Hammock on the box and force of Mr. Jordan on the box are also equal.
Incorrect. That is incorrect.
No, what?
It's incorrect because the force of Mr. Hammock on the box here is unequal to the force of Mr. J on the box, which is 60 newtons. And mine is right, so...
Second question. Explain one difference between a series circuit and a parallel circuit.
In a series circuit, the current through each of the components is the same, and in a parallel circuit, the total current is equal to all of the currents added up.
Correct. Given that every centimeter represents 10 meters per second, determine the magnitude and direction of this vector if it is 2.4 centimeters in length.
So for this one, the direction is going northeast and is also going forward. So for the magnitude, I multiplied the 2.4 centimeters by the 10 meters per second, which is equal to 24 meters per second, and that is the magnitude.
That is correct. And Isabella takes the lead with a score of 200 versus Emily with a score of 100. Next question. Explain Newton's second law.
I got it. Newton's second law of motion is the vector sum of the external forces on an object is equal to the mass of the object multiplied by the acceleration vector of A, which is technically force is equal to mass times acceleration.
Dang it.
Next question. An airplane accelerates down a runway at 3.2 meters per second squared for 32.8 seconds until it finally lifts off the ground. Determine the distance traveled before takeoff.
I got it. Okay, since we know the airplane's acceleration and the time it takes to take off, we use the equation change in x equals 1/2 acceleration times time squared plus velocity initial times time. And then we take the change in x equals 1/2 and we plug in the acceleration given to us and we multiply it times the time given to us squared. And then we add that to the velocity initial, which was 0, and then multiply that times the time. So then the change in x ends up being 1,720 meters.
If Izzy runs at Campbell at 12 meters per second and is 65 kilograms, how much force does she exert on him during collision? The time it takes for the collision to take place is 1 second.
I have a force. So using the equation F equals ma, we know that A, acceleration, is equal to change in velocity over change in time. So the new equation is force equals mass times change in velocity over change in time. So then, and we know that the mass is 65 kilograms, the change in velocity is 12 meters per second, and the change in time is 1 second. So the force is 780 newtons.
Isabella and Emily are now tied at a score of 300 each. Identify the crest, trough, amplitude, and wavelength of the following wave.
In this diagram, the crests are the 2 blue dots at the top of the wave, whereas the troughs are the 2 red dots at the bottom of the wave. The amplitude is the green line because the amplitude only goes from the crest to the median or the trough to the median. The wavelength is the distance between the 2 blue dots or the 2 red dots.
Next question. If Kendall is standing on a diving board 20 meters above the water and is 60 kilograms, how much gravitational potential energy does she possess?
So for this one, I use the equation gravitational potential energy is equal to the mass times the gravity times the height. So this is 60 kilograms times 9.8 newtons per kilogram times 20 meters, which is equal to 11,760 joules.
Next question. Determine the force of gravitational attraction between the Earth, where m equals 5.98 times 10 to the 24th kilograms, and a 70 kilogram physics student, if the student is standing at sea level, a distance of 6.38 times 10 to the 6th meters from Earth center.
Got it. So I use the equation. Force is equal to G times M1 times M2 over D squared. And so when I plugged every single number into the equation, as such, I got 686 newtons.
Isabella takes the lead with 600 points against Emily's 300 points. And that concludes today's showing of Physics Jeopardy! First question. A 4-kilogram box is being pushed out.
I win.
Next question.
Campbell! God. In summation, this is... Stop laughing at me!
In summation.
Force is equal to gravity times...
Nope.